Dear students, let us start with the NCERT exercise of the chapter Motion in One Dimension. And the first question is, in which of the following examples of motion can the body be considered approximately a point object? Now the question is, what is a point object? A point object is considered to be that object if the size of the object is very small as compared to the distance travelled by the object. In that situation, the object is considered to be point object. So, first point is a railway carriage moving without jerks between two stations. So, you can say a railway carriage is having the size, you can say almost 5 to 10 meters, but the distance between the two stations is in kilometers, and the railway carriage has to cover a lot of distance. So, the railway carriage is considered to be the point object. Yes, the answer of first point is yes, it is a point object. Second part is a monkey sitting on the top of a man cycling smoothly on a circular track. In the figure, a circular track is shown to you and the monkey is starting from one point and moving along the circumference of the circle. So, as compared to its size, the circumference of the circle is very large, and hence the monkey is considered to be as a point object. Next is a spinning cricket ball that turns sharply on hitting the ground. Again, the cricket ball is very small and it has to travel a very large distance when it hit the bat and then move to the ground. So, the spinning cricket ball is also considered as a point object. Fourth one is the tumbling beaker that has slipped off the edge of a table. This is shown to you in the figure. The height of the table is maximum 2 feet and or you can say 3 feet. So, the beaker when is dropped from the top of the table to the ground, it travel a short distance. That's why the tumbling beaker is not considered as a point object. Got it? Let us switch to the next question. The question is, a jet airplane traveling at the speed of 500 km per hour ejects its product of combustion at the speed of 1500 km per hour relative to the jet plane. What is the speed of the exhaust gases with respect to an observer on the ground? So, let us consider that the plane is moving in the upward direction with a speed of 500 km per hour, and you know the exhaust gases come in the opposite direction, that is in downward direction. This 1500 is the relative velocity given to you, the relative velocity of the exhaust gases with respect to the ground. So, you know what is the formula for the exhaust gases. The formula is the relative velocity of first with respect to the second. Now, here we are calculating the relative velocity of the exhaust gases with respect to the airplane. So, jet plane is having velocity v1 and the relative velocity is 1500. So, we take the minus sign because the exhaust gases have its velocity in the downward direction. So, the formula for relative velocity is v2 minus v1, and that is equal to relative velocity of the exhaust gases with respect to the ground. By putting the value of relative velocity, we can calculate v2 here. It comes out to be 1000 km per hour. This minus sign here indicates that the velocity is in opposite direction. You know, the jet plane is moving in upward direction and the exhaust gases are moving in the downward direction. The answer is 1000 km per hour. Next question is, A car moving along a straight highway with a speed of 126 km per hour is brought to a stop within a distance of 200 meter. What is the retardation of car and how long does it take for the car to stop? What is given in the question, students? A car moving along a straight highway. The speed of car is given 126 km per hour. So we will convert it into meter per second. And the distance is given 200 meter. When brakes are applied, it will stop at a distance of 200 meters. So distance is given, that is the stopping distance. It means the final velocity is 0. And what you have to calculate? The retardation and the time for stopping the car. So u is given to you 126 km per hour, stopping velocity that is 0, final velocity, because ultimately the car is going to stop and the distance is 200 meter. So by applying the third equation of motion, we can calculate the acceleration, and that acceleration comes out to be minus 3.06 meter per second square. This minus sign indicates that the person in the car is applying brakes. That's why it is known as retardation. And by using the first equation of motion, v is equal to u plus at, we can calculate the time. After 11.43 seconds, the car will stop by the application of brakes. Now question 3.8. On a two-lane road, car A is traveling with a speed of 36 km per hour. Two cars B and C approach car A in opposite direction with a speed of 54 km per hour each. This figure is showing you that the car A is in the center and car B and C are approaching from opposite side. The car B is moving in the same direction as that of A and C is approaching in the opposite direction. The speed is given to you as shown in the figure. And next is, at a certain instant when the distance AB is equal to AC, both being 1 kilometer apart, B decide to overtake A before C does. What minimum acceleration of the car B is required to avoid an accident? First of all, understand this statement. The car A and B are moving in the same direction, that is towards right hand side, and car C is moving towards left hand side. The situation approaches when the distance between A and B is 1 kilometer and distance A and C is 1 kilometer. It means B and C are now at 2 kilometer apart. At that moment, the driver of car B decide to overtake car A. He want to overtake car A, and for overtaking, what he has to do? He has to increase the speed of his car. And now you have to find out that acceleration with which the speed is increasing so that there is no case of accident. It means before approaching the approaching point of C, the B has to overtake. Now what you have to do now? Now you have to calculate the time in which the car B approaches car A and the time in which C approaches to car A. And before that, B should, because speed of both the car is same, so B should increase its speed so that it can overtake the car A. For that, first of all, calculate the time taken by car B to overtake A and time taken by car C to cross A. For that, calculate the relative speed and then time. Here, first of all, you convert the velocity in meter per second and find the relative velocity of C with respect to A. That is VC minus VA, that comes out to be minus 25 meter per second. And C has to travel a distance of 1000 meter, that is 1 kilometer. how much time C will take to cross A, that is distance upon velocity, that is the relative velocity, and the value comes out to be 40 seconds. Now, in order to avoid accident, then B must overtake A in a time less than 40 seconds. So, the relative velocity of car B is 5 meter per second. The distance is 1000 meter. The speed is 5 meter per second, that is the relative speed, and time is 40 seconds. For in 40 seconds, calculate the acceleration. The distance is 1000 and put in the second equation of motion, you have the acceleration 1 meter per second square. It means the car B to overtake car A requires an acceleration of 1 meter per second square. Got it? This is the most important question. 3.9 question NCERT exercise. Two towns A and B are connected by a regular bus service with a bus leaving in either direction every 2 minutes. A man cycling with a speed of 20 km per hour in the direction A to B notices that a bus goes past him every 18 minutes in the direction of his motion and every 6 minutes in opposite direction. Then what is the period T of the bus service and with what speed do the buses ply on the road? In the question, understand the statement first. The two towns A and B are connected by a bus service. Here a cyclist is shown to you. The cyclist is moving with a speed of 20 km per hour, and the speed of bus you have to calculate and the time in which the buses are plying from the station A to B, that is T. You have to calculate these two things. So consider the velocity of the bus is v km per hour and the cyclist is moving with 20 km per hour. So what the cyclist is observing, he is observing that bus is passing him in every 18 minutes if the bus is moving from A to B, because the cyclist is also moving from A to B. When the bus is moving in the direction of cyclist, it passes the cyclist in 18 minutes. But when the bus is coming in the opposite direction, that is towards the cyclist is also moving, then the bus is passing the cyclist in 6 minutes. So first of all, to calculate the distance, we have to calculate the relative velocity of bus with respect to the cyclist in both the cases. When they are moving in the same direction, then their relative velocity will be difference of two velocities, and when the bus is moving in opposite direction of the cyclist, then the relative velocity will add up, and the time is given to you. Time for the same direction is 18 minutes and time for the opposite direction is 6 minutes. So one point is clear to us. What will be the distance? Distance will be velocity into time. In both the cases we have the distance. Now one more question is given here, that the bus is leaving the station A in every 10 minutes and also from B in every 10 minutes. It means the total distance travelled by the bus and the total distance travelled by the cyclist with relative to the bus. It means with the relative speed must be equal. So let us solve it. Let the speed of the bus is v kilometer, and when the bus is moving from A to B, the cyclist is also moving from A to B. The relative velocity of bus in the direction of man, that is v minus 20, and then the buses are crossing the cyclist in every 18 minutes. So distance travelled will be relative velocity into time. The time is in minutes, so change it into seconds. So 18 by 60, this is the distance that travelled by the relative velocity of man and bus. But for the bus, the velocity is v, it is leaving in every t minutes, so time is t by 60. These two distances must be equal, so put them equal and name it equation 1. And for the second case, when bus is moving from B to A, then relative velocity must be added. Again calculate the time, v plus 20, it is crossing the person in 6 minutes, so 6 by 60, and we have the distance travelled by the bus, both must be equal, let it be 2. So solving these two equations, we have two parameter here, v and t, and we have two equations. So the easiest method we can adopt, that is dividing 1 by 2. We have velocity 40 km per hour, this is the velocity of bus. By putting the value of velocity in any of the equation, we have time as 9 minutes. So in every 9 minutes the bus are leaving the station and the bus is moving with 40 km per hour. Okay. Question 3.11. Read each statement below carefully and state with reasons and examples if it is true or false a particle in one-dimensional motion. The first part is, with zero speed at an instant may have non-zero acceleration at that instant. So first of all, brush up your mind which situation is showing this. This is the condition of free fall. When any object is dropped from a certain height, what happens? The initial speed is 0, but it is moving completely under the effect of gravity, so acceleration is 9.8 meter per second square. This fits to the situation, so this statement is true, and this is true under the condition when a body begins to fall freely under gravity, its initial speed is 0, but its acceleration is non-zero, that is 9.8 meter per second square. Part B is, with zero speed may have non-zero velocity. Again, assume the situation. If the speed is 0, it may have non-zero velocity? No, because the velocity is speed plus direction. The speed having the direction. If speed is 0, then velocity is 0. So the second statement is false. The next is, an object move with constant speed but have zero acceleration. Is it possible? Yes. When a particle moves with constant speed in the same direction, neither the magnitude changes nor the direction changes. In that situation, the speed and velocity are equal. When speed and velocity are equal and velocity is constant, then the acceleration is 0. So the third statement is true. The next one is, with position with positive value of acceleration must be speeding up. It means if the acceleration is positive, the object's speed is always increasing. No doubt, in every situation we consider that when we increase the speed, we accelerate the object, that is known as acceleration, and when we apply brake, the object is speeding down, that is retardation. But one case is there, and that is the case when any object is thrown in the upward direction. In that situation, the acceleration is negative and the object is speeding down. And if we drop the object, what happens? The speed increases and acceleration is positive. So by considering all these situations, we have that the fourth point is false. This is not possible that the object is always speeding up, is having the positive acceleration, which correspond to the example. If the initial velocity of a body is negative, then even in the case of positive acceleration, the body speed down and a body speed up when the acceleration acts in the direction of motion. So one case is not following this statement, hence it is false. Then now question number 3.18. A police van moving on a highway with a speed of 30 km per hour fires a bullet at a thief's car speeding away in the same direction with a speed of 192 km per hour. Here 192 km per hour is the speed of the thief's car and 30 km per hour is the speed of police van. If the muzzle speed of the bullet is 150 meter per second, with what speed does the bullet hit the thief's car? Muzzle speed means the speed of bullet, that is 150 meter per second. Understand the question that the police is sitting in the car, that is in the police van, and they are firing the bullet. The bullet is also moving and the car is also moving as well. So the total velocity will act as a system and you have to add both the velocities, the velocity of police van and the velocity of the bullet, and the relative speed of bullet with respect to ground will be the sum of these two velocities. So what is given to you? Vp, the velocity of police van 30 km per hour, convert it into meter per second. Speed of bullet 150. The total speed of the bullet considering the velocity of police van with respect to ground is Vb plus Vp. Now the Vb plus Vp after solving comes out to be 475 by 3 meter per second, and the speed of thief's car is given to you, that is 192 km per hour, and convert it into meter per second, that is 160 by 3. Now you have to find the relative speed of bullet with respect to the thief's car, that you have calculated earlier. The speed of bullet, that is 475 by 3. The speed of thief's car is 160 by 3. So difference of these two values, because both are moving in the same direction, the difference of these two values give you the relative speed of bullet with respect to the thief's car. That comes out to be 105 meter per second. Hence the answer is 105 meter per second. Now this is all about the NCERT exercise of the chapter motion in one dimension. You people try these questions, note it down in your notebooks. If there is any query, you can call me.